So let's repeat this. We start with data that I'll give you, and let's make it a bit more practical here. Housing prices in Boston or New York or New Hampshire, wherever the data set that you've actually selected could be any kind of data, any type. And I take that data and I do some work on it to actually label it, start giving it labels or numerical scores or something that says, okay, these rows of data, and I'm going to take these different values that assemble like one row of data. This is a score of 50, or this is a good outcome. Or if I take, this would be the housing price. So to make it, again, to try to drive it even further, I take the square footage, the neighborhood, the number of bedrooms, the size of the yard, the school district, whatever those parameters are, that gives you $700,000 for the house price. Then I go to the next record. This much square footage, this many bedrooms, blah, 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 like all these. And then I just give it hundreds and thousands and hundreds of thousands of these examples for a particular regional area. And I put it through a training algorithm. There are different types, which we'll talk about in a second. Then we actually end up with the output of this is going to be an algorithm. It's an actual trained algorithm that I can give it new, that I can then feed it. I say, hey, I've got a new house that came on the market, and I feed it to that algorithm, and the algorithm will predict what the price of that house would be. The label is the price. It could be. So Emily, it's based on the data set. What they call them features. What attributes are going to be the most important for that machine, like to learn and understand, would be the feature set or the attributes, and the labeled data would be, in this case, in the case that I just described, would be the price. The other one could be a score, like in which we're going to look at an example for mall customers and spending based on annual income, a scoring algorithm that actually gives them a spending score in the mall. They score it from 0 to 100 based on their annual income. They give them a score based on data, etc. So for that, the labeling of that data would be that that particular score. Any questions on difference between traditional programming and machine learning? It's pretty easy, I think. It's not difficult to grasp. Would you agree with that? All good. Any questions on that? Traditional programming has rules, operates on data, gives you output. Machine learning takes labeled data or data and its output. You put it through some kind of a training, and then it gives you a trained algorithm. Good there? Moving on. Okay, now how do machines learn from data? This is just a kind of a simplistic way for you to start thinking. Now we want to kind of elevate our thinking and then start saying, okay, if that's how machine learning works, and now I want to see what are the steps, what's the pipeline that I have to work through in order for me to start using this concept. And we usually look at the data itself, and we're going to talk in the next slide in a bit more detail about data, but we're going to look at the feeding that historical data and making sure that that data is something that can be used. It's labeled properly, and we train the model on it, and we test the model on it. Then we actually do the prediction. So we actually put it out in production, or we put it in front of a customer or whatever. Then we start working on model improvements. By the way, this has been running in our financial institutions for decades. This is not something that's just happening. So fraud detection, when you guys get a kick out of a transaction, when you're trying your card, it's usually doing a fraud detection. So that's a logistics regression, which we'll talk about what that means in a second, where it's actually saying this transaction for this customer, is this fraud or not? And then the trained algorithm would come back and say, this is a fraudulent transaction. So the system will kick it out and they would reject the transaction. This has been running for decades, right? So this is not something new. It's just that the whole craze of generative AI is surfacing all these things that a lot of the industries have been using AI for many years, And that is a concrete example that everyone has experienced, most likely, in using a credit card. And there are different classification algorithms. We'll talk about it here in a second. Now, for the different types of machine learning, there's what's known as supervised learning, right? Unsupervised learning, and there's reinforcement learning. We're going to look at all of these kind of quickly, just to give you the broad picture. Our focus for today will be on supervised learning, but we're going to cover, in this slide, we'll cover all three, just to make sure that you have a baseline understanding of all the three of the different disciplines. Now, supervised learning uses that labeled set. The reason that it's supervised, by the way, supervised, unsupervised, and at the end of the day, there's a human involved in all of these anyway. That unsupervised learning doesn't mean that, my AI assistant or my AI algorithm wakes up one day and decides to go learn on its own. That's not what is meant by supervised versus unsupervised. What's meant by it is that in supervised learning, you're being very prescriptive in saying, here's a data set. In this data set, this is good, this is bad, this is indifferent. So that's why it's more supervised. It's more about trying to create a model that will be able to use our supervision of good, bad, indifferent, and create an algorithm that can fit that data to be able to produce future predictions. That's what's meant by supervised. And it focuses on prediction and classification tasks. Now, what's the difference between prediction and classification? At the end of the day, they're all prediction, right? But prediction is about giving you a value. So I'm going to give you housing prices. I'm going to train you on that, make sure that you do a good job. And then you're going to start predicting future prices for new houses that show up on the market. Classification, on the other hand, is binary, usually. Like, it could be more than one value, but usually it's like, is this fraud? Is it not fraud? Kind of a thing. Is this customer, are we going to lose this customer or are we not? Like churn data, when we look at customer data. So in the supervised learning kind of column, we need to have training data with known outcomes. And the biggest, most royal pain in the ass with all AI projects is data and having good data. In the session today that we were talking about, the TCLI did a study recently where we were trying to use AI to actually understand the volume of data that's being generated. And I think the daily volume, the last read was the daily volume was 402 million terabytes of data per day. Compare and contrast to 1992, 1993, it was even like the first decade, there was no more than a few gigabytes per day flying across the internet. Today, there's 402 million terabytes of data. Okay. Now, so the reason that I'm telling you this is that this kind of got triggered from the fact that the biggest pain in the ass is data, because even for an organization, the biggest problem that we have is that we have a lot of unlabeled data. There's a lot of data, but it's not labeled. Again, today I made a reference to working at a bank where we had 30 years of legacy data, and we just kept copying it from system to system, to data center to data center. And we did not get rid of it because we know that that's gold and we need to use it, but we just don't know, we didn't know how to use it. I mean, while I was there, we figured out some uses for it, and we used AI and enterprise data warehousing and things like that to actually leverage that data. But most organizations, don't be fooled, most organizations today are just copying data, and they're sitting on that data, hoping that it will hatch, and it's not going to hatch, without actually going through the exercise of labeling that data, so for you to be able to extract some value out of it.